Okay, everyone, so let's get started. We will try to do a few problems today and practice as well. The first one would be number of islands. Let's start to white. So here, the problem says, given an binary grid, which represents a map of one and zeros, land and water, return the number of islands. An island is just surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Lands connecting lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So these all, like zeros. Okay, so let's try to play with this example. We're just adults. So, okay. First of all, what I would like to hear of this. This is like this whole grid that we see with ones and zeros are surrounded by zeros from everywhere, like zero, 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 zero. And the way it works is, okay, so let's see what we can do. So this is, okay, firstly we will do we try to see do brute force of whatever we have, whatever we, however we get the solution, and then after that we will try to optimize and see what other methods can end up applying. First of all, this let's count the island 1 1 1 1. This is all this whole chunk will come to this one island because let's remember what we had. We have one and we have right uh, up and down. Horizontally and vertically, an island is surrounded by water and is formed by connecting lands horizontally and vertically. So this is a land, and these are the four connections on four sides. So this will be connected to this is connected to this is connected to this, but to its left it's zero, its left it's zero, on top it's zero, uh, and so this to the right is zero, to the right is zero, below it's zero. So this is a separated chunk with ones in this setup. And that's how we get like it is counted as one island because there is no diagonal connection available. So this whole chunk will be another island, and because left, right, top, bottom, it's like all surrounded by water. And same for this chunk. It's also one island because we're trying to make better because safe for them. Okay, and separate entities of lands. So that's from where we get the count three. If I wanted to brute force that, what would I do? The first thing that I uh, let's let's try to know is how would I count it out on a brute force? One. Okay. Uh, I can think about is if I start counting from here, um, count all the chunks in separate. This is one, this is one, this is one, one. Let's try to come to the here. How do I implement that in code? So I will start counting this one and see to its left and right position, top and bottom position, then until once. If there one, so for brute forcing this problem, I can only think of one approach that is one and having like the graph with the four edges. So here, to its left it's zero, right is one. We're talking about the specific this one. So now it's one little dot it's zero. And if I end up having such a map for every position, and so I try to see what left is one, right top is zero. I have such a thing for each position. When I end up counting, that's a good thing. I really don't know the best way to visualize brute forcing this. If what about that's the one thing. So this is where I was stuck at. For a while, when I hit pull-up, we have two possibilities. Either it is already a part of an island, or it's the first time we're encountering this item. And we basically need a way that had to be explored. So, okay, okay, that makes sense. Yeah, so we can end up having, actually, we will do it that spots. We will retain visited cells via visited role. Oh, oh. We can use this knowledge for our benefit. So whenever you're traveling for so so we will iterate the way I can reinforce it will be the I'm gonna over it, then urge that that grid in that specific cell uh, one that is allowed. And if it's a land, and if it's not visited, then it's the number of items. As we've just seen over there, it's like one, zero, 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 one. And the one, zero, zero. So we have like three islands over here, and suppose we start brute forcing it, then we go there and see column like this condition, it's true. We increase the count to one, pound becomes one. Uh, then we go to the next cell and we see if if returns to the column and visited. and this is also not visited yet, then we will increase the count. That shouldn't there should not increase to because there's a draw. They'll migrate to the home if it's one. And yeah, I think what we will have to do is when you're taking conversion, we will have to make sure that uh, to go to the focal conditions. So that's gonna be mm, so we will it's not like that. So the thing that I was thinking, uh, if that specific land, if that specific cell is a land, and all of its four visited, all of its four adjacent cells, which is for this one, the adjacent cells will be this, up, and down, right? So we will have to check all of them for the force. So if grid row column is equal to one, we already have found as one, found as one, and we would check the for this position visited. I think I'm looking at the total of this row. So it's row column plus one, column minus one. Oh, let's put this in there. Row column plus one, same row, column minus one, then column plus one, and column row two. If all of these are satisfied, only then we will go. Otherwise, we would only then we would increase the count. Otherwise, we won't increase the count. So let's try to brute force that logic and see do a try run. So this one turns out to be zero, and we also because this is not satisfied, it's covered in this cell. Then for this position, this condition will be satisfied. So we will increase the count as two, increase the count as three, then we get here. So I think this is a valuable brute force. And now on. So, yep, that's it. And the title that's say about this would be um, traversing the whole thing. So in squared, the space complexity for this problem would be visited opens because visited for every zone. So it's not n squared basically, it's in the cross. Then let's try to do that with special. That makes sense. But the optimal solution would be using a graph. Suppose we start here and end up, we can explore all its neighbors and mark that we can increase the power, explore all the neighbors, and at that point the count will be one. So we're done with this. Then we get here. We can explore all the neighbors of the count. When we get here, we explore all the neighbors, update the count, and then we get here. When we get here, we would. That's a good place. Let's see what I'm doing wrong. So when I'm here, I will visit all its neighbors and will update the count to the count. Then okay, keep on traversing the neighborhood here. I will trace all its neighbors. So this is out. Yeah. So update the contents. So then when I'm done, I will come here, visit all the neighbors, update the count to 3. Then when I oh, I think I know where I'm getting it from. So it has to be depth for search. Um, you have to keep going and you can't just stop seeing. So if I'm like traversing this, I wouldn't just stop exploring this thing. Okay. I think I remember the intuition now for this problem. So this way, you would never get to the count because you're counting the neighbors that this specific cell, the neighbors that this specific cell had to offer, because that technically will be like this is also included in this count chunk, right? So for that, you would have to do DFS, depth first search. Once you find a new node, you start digging into it and get it done. And how that would help us see, we have, if I do the brute force thing again, we will see a new neighbor. We just uh, let's run it. So the equation is when you start here, what the neighbors? This one. So that's the only one that's left, right, top, bottom. Only this one's neighbors existing. And when we dig into it, left, left is already this, which is included in the count. Right is zero, top, bottom is 0. So we get done with this jump. So I'll take this. This is all marked as 0. This is all marked as 0. And then, oh yeah, that's a good thing you can do. So I'm gonna start the example from scratch because it's gonna be a bit easier. So we have 1, 1, 0, 0, 1. Oh, 1, 1, 0, 0, 0, 1, 0, 1, then 1, 1, 0, 0, 0, right? So the thing that we will do is we start from here, includes an account, which will be 1. And when I explore its neighbor and explore the neighbors, which is this one, I'll show up here and mark it as 0. Then start exploring this node. So when I explore this node, it's 0, it's 0. Now the neighbors have nothing to be explored. So I'm done with this chunk. Then for this position, when I show up here, I will increase the count first of all, then then explore its neighbors. Its neighbors are left, right, top, bottom, so only this one will be explored. When I show up here, I will explore its neighbors. Left, right, left is 0, left is 1, right is 0, top is 0, this is we will explore 2. So this is done. Increase the font to for this specific chunk. Similarly, for this one, we would get 3. For this one, we would get 4. 0, and that would be like 4 items. So I know this kind of makes sense, but yeah. So brute force was maintaining that visited row and column thing for all the neighbors, but the better way would be to do a graph traversal DFS. Like when you find a new node, like a distant node, which is also one, just dig into it. So let's see what we can content code it up. Um, so if a number from this, we would need a count for those patterns. So INT those will be with the size, columns with 0 size. Once I'm done with that, so I'll start iterating. So we'll do now INT as computer is less than plus 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 behind the change frequency, which is less than follows chain plus plus. And for this setup, what we will do is basically check if grid of I j is equal to 1. If it's 1, then we will be considering run DFS. How we would run DFS? It would be, let's visualize it. We would pass the row column, we would pass the whole grid, and actually, take a look. Okay, and we would increase our count. Let's say we would have 100 is equal to 0. So every time I see a grid, which is a land, I would start digging into it. And this, what it basically does is this portion, like when I'm starting here, I will make sure that this is also explored. And when I'm done exploring this, I will also explore its neighborhoods. So this is also done. And for this one, it's a dead end because left, right, top is already explored, bottom is 0. And when I say it's explored, I mean that it's turned to 0. That's what we have determined. That's how we determine whether it's explored or not. And at the end, we should do like return time. That's it. So now the core implementation is just basic to our the first. So let's say we have ref traversal, and say we would have int chain, and since row column is full vector of vectors, um, integer. What did I? Sorry, there's something there too. Chain. We will do as by our friends. We don't want to spoil the main setup, which is referencing we don't want to make a new grid object every time. We're just using the same grid and passing it off so that I can have one centralized map to track actions. Since it's a character, we would have to have here one. Uh, and yeah, so let's see what else we can do. Since I will be needing these rows and columns, I will just say that as I'm here. So we can end up using rows and columns over here as rows. So basically what I need would be a few here. So we need the neighbors, to need the neighbors, or we need the directions, which is basically let's return small. And it will be left, right, top, and bottom. So I will be using vector of like rows and columns, right? So chair of integer thinking. However, shouldn't be a problem. Let's see. Let's have it. Vector of pair of integers, probably reference. Um, we have a few of them. 1 0 0 1 plus 1 0, then we would have minus 1. So few of them over here. Um, so this is basically reference to the same different top bottom thing. And the way we would use it is like adding the with the current ing position. So if I want to move forward, DFS, right? So what's the number of DFS basis? We need a queue. Uh, so let's say we want a queue of integer, no, queue of pair of integers. So it's queue. So initially, what we would do is we would queue the push that specific R and C one column, and then we would mark that thing. So grid R C is equal to 0. After that, what we can do is while the queue is not empty, we'll keep exploring it. So uh, initially, let's see what's in the queue. We would do auto and u dot. We grab the value on top and do u dot fall. U dot fall. Once it's done, um, once it's done, oh, I think I said it wrong. Q dot front grabs the element from um the bottom, right? Yeah, I do Q dot front of yeah to the first and oldest element. That's right, because the way I was visualizing is I have a queue here, like 1, 2, 3. So I would oh I don't know. I have a queue here, uh, 1, 2, 3. I would be keeping elements over here and then removing it from there. So first in, first out. So that's why I went with bottoms. So let's see. Uh, until it's not empty, we will keep going and get uh, for auto. Now we'll do the reversal. So for auto, I and J directions. Uh, we would T R is equal to M plus I. The C1 is equal to N plus J. Then if grid R1 C1 uh, is equal to 1, that is also on land, only then we would start DFS from there as well. Oopsies, not start DFS like that. We would do push R1, R1, C1. And when we do that, we would also make sure that um, that specific cell read of R1, C1 is equal to, we'll bound check over here because we don't know what it's going to be. R1 is greater than 0. So then rows and C1 is greater than or to 0. That's what it's like. Follows. That. See. No one expected. Yeah. Okay. So one other similar kind of problem that I was thinking I would practice is more try to do similar question. Let's try this what's wrong with that. You're given an input initialized with these three possible values -1, 0, and then continues and continues. You use the value to the power 31 -1 to represent infinity even so the distance to the distance and then so that you like that. We have to use an infinity. Use the value present infinity. Whereas even so the distance located is less than is field. So fill fill each empty room with the distance to its nearest gate. If it is impossible to reach a gate, we will fill the infinite. Oh shit. I can do one for this one. So for each position, we would have three values. -1 is a wall or an obstacle. 0 is a gate, infinity is a continuum. 2 to the power minus 34. 2 to the power 34 minus 1. 2% infinity. Okay, it's all okay. Fill each value with the distance to its nearest gate. So for this one, what is the nearest gate? Um, it's next to it. Oh, no, no, no. -1 is a ball. So for this one, nearest gate is divided slowly. 1, 2, 3, okay. 3, 2, no. But this one, the nearest gate would be so at this position, the nearest gate should be 2. No, 1, 2, 3, 1, 2, 3, 4. Oh, how the rooms are set up is 2 to the power of 1 log, infinity. Oh, so presents an empty room. Empty room. Yeah. So mm, it's gonna be tough. Okay. Okay. So let's see what we can do. Okay, first solution would be basically just counting the nearest one. So uh like when I'm at each cell, suppose I'm at 3. Oopsies. So when I'm at each cell, I would be counting, I would be like expanding further. So suppose I have this position. Just give me a moment. So let's build a brainstorm. What we can do about it. Other than this was a fairly expanded and see shits and play because the game is what? So starting from this position, if I see a wall, I want to expand that there. I will expand the items. So this I will expand, this I will expand. And if I see that gate, I will just stop it. So from this position, it's going to be distance of 3, so distance of 1. Same for this. So from this position, I start expanding all around the corners and trying to see if this there's both I can go top and I can go. Does it's the law? One, two, so I will keep expanding this. So that's gonna be like zoom. Oh, no. It's gonna be like one, one step here, one step up there. So two, one step up there, one, two step up there, two step up there, one step to the left, four. Yeah, I think I have like mm, a solution for this now. Mm, For each position, we have key options for it. And we will basically make sure that we have the, what is the question? It, it's nearest key. That's not the problem. It's expecting me to, oh, for get the nearest key. The way I get it was basically, I think I can wait on DFS. Like, if I get a gate, if I get a gate, I'll just pull out. That could be extra. Like I would rely on DFS itself. Is remember like the same theory of using like when I get a neighbor to explore and I see how many pops into it. So so I would explore for directions. That's like no brainer. Um, yeah, I don't, my I'm staying in this whole world. What do they want them to? Let's see this one zero. So, oh, they just want to update things, deals, this one, this one. Yeah, let's see. We think I have a good grasp of the problem now. Can literally start looking into it. Mm, yeah, let's say long game. So then we would first do the rows and columns. That would be rows is the summits and columns would be rows zero. That's it. Now that's one and I want to know. I think it's list the rows. Let's see. So it was zero. First, one, plus one intuition that I think I should be explaining is this. So for the last problem, let's say what was it? I don't think I'm in the right word of the middle. So it's called the non but I do this still. Let's see. Oh, no, it's oh, look at that. What's the problem I did yesterday? Oh, and I yeah, receivable interests. So for occupancies for a number of items, the thing was suppose okay, suppose I do this whole chunk. So okay, so when I start here at this point, I don't have any specific requirements, so I just want all its adjacent neighbors to be explored and turned to zero. I want this whole big section to be zero. I want this section to be zero and this section to be zero. So once you get to a neighbor, you start exploring that neighbor and why exploring, we just bring to zero. So that's one aspect for wormholes and games. What's the difference? So let's see. I would uh, heal at this position. Then there's the gate on the okay. This position. Start with this one here because it's not like a wall. It doesn't take the close up wall. Oh no, it's all marked as up from the back. So in this case, I grab that number and so if it's infinite, I can start exploring. Then then pass it up. That's right. So wherever we would have info, should we just put it in the queue? Yes, how do I structure the prompt now for, I know it's a DFS probably. Oh, that part for sure, because that's what I know. They're really good traversal. DFS is near the traversal. Like, I don't know how to structure the problem. So, let's see. You have this starting from here. Mhm. Distracted for a few minutes. Um, instead of starting, so what I was thinking is I would pull, I would like, I would put the infinities, like these positions as a king. Is that a king there? Why would I just put this thing over there on the king and start expanding outside of it? If I do that, it would be like one, one. This position would be like two, we can do two, and then this position would be three, then the fourth one of reversal, or so here would be, how do I merge concepts? So for this position, I start here. If it's clear one, then this clear one, clear two. At this position, what do I do? It's it's gonna be clear three, clear two. Series when we want to be consistent, we would go with the I think that's a viable solution. I think about Mhm. Yeah. So let's say we would have to and, and the main problem with with this the main thing with this problem is we're not dealing with one specific possession. It is basically a multi-source problem. Remember for the last one, it was if you start from a position and you don't hear like number of islands, you start off from here and then you don't care about the whole grid thing. But here you can be doing that because you need the closest to that specific temple. And that could be from any different temple of sorry, sorry to the one in the case. That it was like that can be from any so and with the many there's no questions about it. So it's gonna be a multi-source problem wherever we will have that uh, gate zero. So whatever initially is that red um, zero is equal to zero. Is an integer, right? Yeah. If it's equal to zero, then I would do q dot first. I would just window the q out here. No, I can just pass it. So let's say we will have vector vector here. uh, so, you know, Actually, for all the positions where we have temples, we will just finish and check. Once we have done, we would start the traversal. Um, that's only Still here. Smash the rules. Let's see. What would we do? So, thinking about it, and doing specifications in some specifications in the queue. I would basically start count from that position on. So what I do is grab the middle pins. So only do that you have a separate little function. So what I would do is I would need the queue size first. So mm, for the rest, then rating. And then since it's you have to account for each of the positions, I will need the queue size. Uh, I was less than for each of the positions, like for this, for each of them, I would have to explore the neighboring cells and decide that stuff. To what to order. And zero, one, zero, so, so, zero, and zero, this one. So that's it. So for each of the segments, we would constantly grab the given position of the and then sleep on the killer from not to that you of pop. When I'm done with this, I would be basically practicing it on how do I do that? What's up? Okay, after I'm done with this, that specific. uh, Yeah, I grabbed that element from the queue. I popped it because I know it can reprocess it. Then I would be moving forward with this piece, which is to CD plus and one is equal to C plus N. Once I grab that, so yes, it's in voucher to equal to zero. R1 is less than rows. And one is greater than R. greater than or equal to zero, zero is less than columns, and also that can't be minus one. Um, so these positions, and I explore these positions cannot be minus one. To be clear, it has to be like all the distances, they have to be infinity. So it's a grid. This called R1, C1, equal to that's the previous. It's empty. It's empty. Like if it's infinity, that's infinity. You know, so on. So yeah, that's suddenly part plus. So use not empty, we got the size of the keyboard and initially the steps was repeat one. So we can go through all the directions and see that cell is valid and that cell is valid, that cell is valid, and that's infinity. In those scenarios, we can assign them to one, then we would start traversing from those positions over that would be the first that push R1 zero. So these cells are turned into one night mode Like this is done, this is done, this is done, and they're pushed into the queue as well. So for seven retrieval, for retrievals, it's gonna be two, it's gonna be two, and those cells will be out. That's what so now this will be done, this will be done. Um, at the end, I would have to know when to stop, right? So whenever it's, let's just try here. Else if v of I is equal to this infinite position, then we would do like, basically what I'm trying to do is like I'm looking at the count, since we had found cells and cells. So these are how many cells we would have to fill up. One, two, three, four, five, six, seven, eight, nine. So I'm just basically green plus plus. I'm sorry, cells plus plus. These are how many cells we would have to clean up. Um, after each position, like between our cells, is nice because that's filled up, right? And we would continue this specific one as long as cells is greater than zero. Mm. The main conflicting part that we do happens if it's already one. If it's not, if this is filled up, this is filled up. This position, one, two, three, one, two. I think that will work because look, here it's fine, it's all, it's two, it's three. But here is I expand. It's one explore all the cells that we can do. And it's one that is all the cells, it's one that's all the cells, except this only one, two, three, four. Sorry, one, two, three, four, five. Sorry, for this position, one, two. For this position, one, two, three. So it's gonna be three for this. If I count from here, it's gonna be one, two, three. So I don't know if it's specific refers to the coordinate. So what I would like you to do is, if it's infinite, it's good. Let's say it's touched for the first time. If it's not infinite, then I would have to go with the minimum though. So steps for the first layer. You can what kind of one? Which vessels being scanned? That is, it's infinity. We would go here, go, go, where if it's an arm. We can also think about it like that. If it's not a law, we would go we would keep expanding if it's a law. So, yeah, what you do, what how do we show a law here? That is one month. So, If it's if if that cell is equal to if that cell is infinite, it's being touched for the first time. So it's touched for the first time. One thing is that this is not on that cell cannot be in a block. This part, but yeah, it's basically that cell is already it's not an infinity. What is the it's the one which you got whatever it is. So that if those circumstances, it's going to be so what is your minimum. Your minimum on like your this is the first time which that is they for particular person to be first is what right person, first is particular person, they would first is to particular so we first is the first part is done the short or trivia see three. So there's no point in a question for the got the first time. Yeah, oh no, we are counting on yes. I don't know. What if God was simply counting on the yes. Oh, for the fears and condition, we are counting on So see, who got their first one? Who got their first one? Who got their first two? And then I will like talk about all of this. Okay, so just to divagate a bit, I don't think I'm missing. I'm not sure what products I'm missing. Problem was, I think the problem I had was if it's not in one, the second instance, definitely minus one for sure, but the thing that I had was it is not minus one, the not log, and has to be in anything. It's not minus one, mm, not minus one, not minus one. You know, so these are all infinitives, right? So we get one. What we get? If I want to move forward, let's try doing a dry run. Not clear. What the bind program. So let's see. Yeah. Okay. Yeah. Go to zero. That is, if it's a gate, then you push it into the queue. Else if the rule is we count the number of cells we need to fill up, then what we would do is basically check size of the queue, and for each of the queue, we update the column first place. So that's gonna be R1 C1 and plus N, that's alright. Use R1 C1 not into -1 because that new rule cannot be unblocked one. And does it have to be infinity or we won't get back to that? But the as it becomes one, becomes one, becomes one. Cells get decreased queue. This so this one gets pushed into the queue. And once I'm done with so for this, that setup, it's not a problem anymore. For the next round, I would get queue these positions and let's see what I do with those positions. So queue size is 3, there's one, yeah, yeah, queue size is 3. We grab the values and see it's not equal to these values are not -1 and these are infinities, right? So we get 2 here, 2 here, correctly. So share on this one. When I'm done with one of the groups, I will install with the so right. What's my confusing? So it's first problem. says have to be one, one, two, zero, zero minus one minus one zero, zero, one, zero, sorry, don't tell me I wasted so much time on this. Okay, the problem was really, really not that bad. So it's just me. Okay, so for directions, we had to just fix the top left right position. So this. I was doing something weird over here. Zero, one. Zero, zero, minus one, zero. Like these are the four coordinates that we will move, right? So think about zero, one. I'm going this way. Zero minus one. Going this way. Zero plus one. Oh, sorry. Zero minus one. Then I'm going minus one, zero, plus one, zero. Okay. Zero, one.